Hello everyone. So in this video, let's discuss the third problem from the AtCoder Beginner Contest 228, problem name Final Day. So the first two problems are not too difficult. Okay, you can easily do them of your own. So I'll start making from the C problem, that is the final day. So the problem goes like this, that there are n students that are taking a 4-day exams. Now every day the exam is of 300 points. Okay, now and the total is obviously equal to 1200 points. Now the first three exams are already over and the students have got their marks. Now you are given the marks in this format. As you can see that the first student will get these numbers out of 300 in the first day, second day and third day. So this is out of 300, 300, 300, and similarly for all the three students. Now you just have to tell that for each student, tell that whether it is possible that he or she ranks in the top K after the fourth day. So after the fourth day, after the fourth exam, whether it is possible that the K student, like all the I student will land a rank from the top K positions. That's the whole problem. Now, okay, also it is written that here the rank of student for the 4 days is defined by the number of students whose total score over the 4 day are higher than that of the student plus one. Okay, so yeah, that's it. Now you simply have seen how ranks are made in your class also. So that's the whole thing, that the scores are given and the I student want to come in the top K ranks. That's the whole problem. Now what you can easily understand is, let's take an example that some students have gotten the rank like 100. Okay, 100 and 100. The second student will get a rank of 101, 101, 101, 102, 102, 102. Just for simplicity purpose, okay. The total for this is 300. The equivalent for this is 303 and 306. Okay, now what you can see here is that what is the worst case scenario. Like, even if you have seen that in your exams, if you want to be in the top, okay, only one paper is left, what is your intuition will be like, you think that okay, I should get the maximum marks as possible and the other students should get the lowest marks as possible, then only my rank will increase. Because in the last exam, the already three exams are gone. Now your most like intuitive thing is that I should have done better and the other students might have done worse performance, and then the total score will be such that I will get a better rank. So the last exam is of 300 marks. Okay, so your intuition will be other like the maximum case possible, because you want to land in the top K. Just think of the maximum case possible, like the maximum extent that I will get full marks and other will get 0 marks. That's the worst case, but still that's a case possible. And if that case happen, then it increases my chance to get in the top K. I don't want to just land into the at least top K ranks. I just want to see that whether it is possible. If it is possible, I will get the full marks and all the other students will get 0 marks. In that case, what is my rank? And if my rank is in the top K, then it is cool. That's the whole point of view. Now if let's say that the first student we're talking about, if the first student get 300 marks, the first student will get a total rank of, let's say, like a total score of 600, and the other students will get 0 marks, so 303, and 0 marks, so 306. And obviously this student will get the top score, and the top score means that the top rank, so this will get the first rank, this will get the second rank, the third rank, and so on. Now also you might understood that okay, this is the case possible if I give this student. Now how to find out the rank? Now to find out the rank, it means that I have to sort the whole array out, and sorting will take a lot of time, because for every marks to be added, the whole array should be sorted out, and sorting will take n log n time, and then that will, and for every student we have to do that, so n square log n time will be done, and it is very large. For n is equal to, like, it is less than equal to 20 by 5. So for n equal to 20 by 5, that will be a very, like, it will be very large time taking, so it will give you to LE. So that is not a valid option. So what you can do here is that I can somehow, if I make my total rank complexity as n log n instead of n, then that is better. Now how can I do that? It means that for every n, for every student, I have to find out whether that student will land a rank between the first K positions in log n time. If I somehow do that, then my problem is sorted. How can I do that? Let's remove this whole thing And just take a random example to even make it more clear. Let us take that the total marks of all the students are like this: 3, 3, 3, 4, 4, 4, 5. I'm just assuming that. Let's say that all the students will get 1 marks in the first exam. This is equal to 3, 3, and 3. Just the total marks. Okay. Now, let's say that I want to get a rank, like get a first rank. So if I want to get the first rank, my total score, let's say my total score till now is, let's say 3. So I should get like more than 2 marks. Or let's say that if I just get the total marks as 300 in the worst case scenario, I will get 303 marks, and it will get me in the first position. Okay, I hope you get the point. So what you can easily do here is that I have to first figure out that how can I find out my position. And if the marks are sorted, if I somehow sort the whole array out, okay, so sorting will take n log n time. If I sort the whole array out, then what I can do here is that I can use binary search to actually find out which position I should land. Okay, because I only want to find out my position. And thus, whenever you feel like I have to do some operation in login, only one algorithm is beneficial. In that case, it is binary search. So think over that direction. So I have n positions. I cannot go beyond that. I have to iterate over all the n positions. So n is required. And now the worst case scenarios, I have to find out the position of my. So login can be used also. So login can be done by binary search. So always try to think in that direction. Now, how can I do that? If I sort this whole array out, okay, after sorting this out, how can I sort them first? I have to sort them by the total score. If I sort them by the total score, the array will be sorted. Now I have to also store somewhere else the original numbers, because I have to get it for all the numbers. If I sort them out, the original state will get disturbed, and I will not know which number I'm talking about. So you have to make 2 copies of students. The first copy is that every student we have to save key. Let's say the first student has a total score of 3. The second student will have a total score of 4. After sorting, it will become like this. But before sorting, I have to store somewhere else. So for the first student, I have to store that the total score is 3. And if I add some score, everyone will add 0. So everyone added 0. So the array will not change, but only this number will be changed. This number will, let's say, become plus 5. I just add, it will become 8. So I have to find out where to place 8. Now I can use binary search. You can write down custom binary search function or on your own, but you can also use lower bound or upper bound. That is also used. Now, if you use upper bound or lower bound, which one to use and how to use that? See, I want to find out the ranking, and the ranking is such that the 5 will be the greater ranking. Like this is the first ranking, second ranking. But upper bound will work on the increasing array. So if according to upper bound or lower bound, this is the first one, first, second, third, and my ranking should be this. Okay, so let's say that I want to rank, or I got a total score of 4, let's say, then my ranking should be second. So it means that I should land on this point. Like if I have to insert my 4 at this point. So it means that if I just use binary search, which lower bound or upper bound should I use? You can easily see that I want to place a 4 like this. So if I want to place a 4 at the end, it means that I want to find out upper bound. So upper bound means that if I have similar numbers, I have to place the number to the last of it. And for that, I have to use upper bound. So they are dedicated blogs on upper bound. You can read them out. So upper bound just place the number just after the occurrence of all the numbers. So I just find out the position of 4. Now 4 will get me a position starting from 1. So if I subtract n from it, the total length, so I will get a position from back. So if this is 1, 2, 3, the upper bounds of 1, 2, 3, 4, 5, 6. So upper bound will get me 7. But I should get 2 instead. So what I can do here is I will subtract, total length is n. So n minus 7, I will get 2. Actually, I will get 1, but as you can see, it is 0th index. So it actually tells me that I am on the second position. So it means that now I have got that my rank will be under 2. And I just have to check that whether the rank I will be placed, if is less than k. So let's say my rank turns out to be 2. And if it is less than k, then it means that I can easily get in that top k position if I get the full marks and the other will get 0. if instead of doing that also, like if I get the full marks and also the other person gets 0 marks, and then also I do not land in the top k position, then it is like, that is the worst case. Like it is the best case possible for me, in which I will get the full marks and other will get 0. In that case also, if I'm not getting in the top k, then like I will not get to top k. So that's the whole thing. So you have to return no, else you have to return yes. So that's the whole logical part for this problem. Let us move down to the code part to even make it more clear. So if I go to the code part, I have to open my submissions. So where's my result? Yep. So what I've done here is that you have to take input of n and k, as well as like you have to first find out what you can do here is that you just iterate over that whole vectors. So maximum is not required. I've just used maximum. It is not required at all. But what you can do here is just to make 2 copies. So one is vector and other is an array. So you can make 2 vectors also, nothing much difference. You just have to take the input of all the 3 exams for every student and push back that particular exam into the vector as well as in an array or a vector itself, so that I have 2 copies now. Now sort the vector part so that the vector is sorted, so that I can do binary search over that. Now what I can do here is I will iterate over the array or the vector itself and add 300 to it, so that this person will get 300 and other will not get 300 marks. And then I will do an upper bound over that person and get its ranking in IT. Then I will just check that I will subtract n from IT, because I have to get the rank from back. If it is less than n, which less than k, which means that I will land in the top k, then only I will print yes, that I can get in the top k with this scenario, that I will get 300 and all the other students will get 0. In that scenario, I will get a rank in top k, then I will return yes, else the answer is no, that I will not get into the top k even if I get the maximum marks and everyone will get 0. So that's the whole code and the solution and the logical part for this video. Stay tuned for more videos. I will see you next one. Till then, keep coding and bye.